Okay, so our task is to find the volume, derive the formula for the volume of this tetrahedron. And so we're assuming that the face, each one of these faces is an equilateral triangle of length S. And so let's take a look at a cross section here. And what I'm going to do to kind of help me come up with a formula for the area of the cross section, which is essentially what I want to do, I'm going to call these sides, I'm just going to assume that these aren't the same. So I know it's an equilateral triangle, but I'm going to call them just A and B for now. And then I'm going to call this one alpha and beta to correspond with these A and B. And I'm going to say that the height of the tetrahedron is h, and then the height from the bottom to where the cross section is located is going to be y. And so then from similar triangles, I know that alpha over A is equal to beta over B. So then alpha is equal to A times beta over B. Now, we also, again using similar triangles, we can see that h over b, so the total height over this side is going to be proportional to h minus y, so that's the height from the tip to our triangle, h minus y over beta. And so then from this, we can see that beta is going to equal to b times h minus y over h. And so then alpha is equal to a times beta over b, so this is a times b h minus y over h, so this part right here is beta, and then over the b that's right there from alpha. So then notice that the b's cancel, and so then alpha is equal to a times h minus y over h. Okay, so now let's take a look at our cross section again. So let's go back to this is an equilateral triangle, so this guy's side is alpha. And then remember here we labeled it beta, but it's really an equilateral triangle. And so that's alpha as well. So since what I want is to do is to find the area of this triangle, then what I need to do is find the height. So this side right here is h over 2. And so then using the Pythagorean theorem, we can easily find that the height is equal to square root of 3 over 2 times alpha. Okay, and so then the area of the cross section is equal to, this is alpha over 2. So the area of the cross section, sorry about that, is 1/2 the base, which is alpha, from here to here, times the height, which is root 3 over 2 alpha. And so then the area of the cross section is 1/2, 1/4 root 3 alpha squared. Okay. So then the volume is simply equal to the integral from bottom to the top, so 0 to h, of the square root of 3 over 4 alpha squared. But of course we don't want to use alpha because that's not our variable. Our variable is we're integrating with respect to y. So we're going to plug in that stuff right here in for alpha. And this is going to be with respect to y. So then what I have, I'm going to put the constants on the outside. Square root of 3 over 4, and then I have a squared over h squared, because all this stuff is squared. Then the integral from 0 to h of h minus y squared dy. And so this is equal to square root of 3 a squared over 4h squared times, if you do this integral, you're going to get h cubed over 3. And so with all this put together, you get the square root of 3 over 12 a squared times h. And that's the formula for the volume of that tetrahedron.